So example, determine quality if saturated or low temperature, if superheated, of the following: NH3, or this is ammonia. This is temperature 20 degrees Celsius and its specific volume of 0.1 meter cube per kilogram. Letter B, also, and this is ammonia, 800 kilopascal and 0.2 cubic meter per kilogram. So determine the quality. So ato we were to draw the T versus V diagram. So again, this is the critical point. Here, and this side here. This is what? This is saturated. Saturated liquid, right? And on the other side, here, this is saturated vapor. Saturated vapor. Okay. So in the previous video, there is an equation that x plus y is equal to 1, right? Where x is the quality and y is the moisture content. So this is in terms of percentage, that the sum of the quality and moisture content is equal to 100%. So meaning to say, so if there is a given quality or there is a given moisture, its sum is equal to 1, or that is 100%. So along this line here, saturated liquid, so meaning this is pure moisture. Given this is saturated, its y is equal to 1. Right? And its quality is equal to 0. Okay? And on this side, right side, if this is saturated vapor, we have your x, or your quality, is equal to 1, and your y, moisture content, is equal to 0. Okay? Is that clear? So in this curve here, this is a mixture of liquid and vapor, okay, at constant temperature. So for example, at this point here, at midpoint, that is 50% quality and 50% ang moisture content. Okay, so again, x is equivalent to the mass of the vapor, and over the mass total, the mass of the liquid plus the mass of our vapor, and y, this is the mass of the liquid over the mass total. This is mass total. Okay, so with that, you have given 20 degrees and 20 degrees Celsius, and if that is saturated, we have, by looking at our tables, the saturated tables, so we have P sat saturated, this is 857.12 kilopascal, and its specific volume, we have 0.001639 meter cube per kilogram. And we have the VFG, this is 0.1477 per kilogram, and we have the VG, 0.1497 cubic meter per kilogram. Okay, so the problem states that we will determine if it is saturated or if it is superheated. So going back in our diagram, so this region here, beyond this this line, this is your superheated region, right? You know that the superheated vapor, this is the temperature is higher than or greater than the T saturation at a given pressure, at P saturation. Okay, so we will determine if it is saturated or superheated. Okay, so in the previous video we have this equation here, equation with specific volume. This is VF plus X times the VFG, right? Or this is X, what? This is V minus VF all over VFG. So these values here is from the tables. Not be confused if it is, depends on if it is water, and then you need to use the saturated water tables or the steam tables. If it is ammonia, if it is freon and other substances, pure substances, you would use those tables. So it depends on the problem, but most of you will use is the steam tables, the water. Okay, so these are the given values. You can locate this one, or you can find these values in those tables. Okay, we have the V given. What is that V? Okay, so at T is equal to 20 degrees Celsius, we have that given. We have this, the V is also given. This is 0.1. This is 0.1 meter cube per kilogram. Okay, so this is 0.1. This is X. This is 0.1 minus your VF is 0.001639 all over the VFG, or this VFG here is the difference of your specific volume of your gas minus of your vapor minus the specific volume of your saturated liquid. Okay, but in these values, these are given already, but if it's given, this is your equation. You can verify that one by this. So those tables are, you have this given VFG. So you can solve this one. This X is equal to 0.1 minus 0.001639 over 0.1477. This is what? This is 0.667, or this is 66.7% vapor. Okay, so the problem states only the quality. What is the moisture content here? So the moisture content, this is Y, this is 1 minus 0.667, or Y, this is what? 33.3% liquid. So it should be that X plus 1 is equal to, X plus Y is equal to 1. Okay, so in your inequalities, you have your inequalities in your algebra, right? Inequalities, can you review that one? So if you have X, those the kinds of interval, this is the open and closed interval. Okay, so your quality, this is greater than or equal to 0, right? Or this is, and also this is lesser than or equal to 1. Okay, Can you follow? So another statement here, this is using your knowledge in algebra, basic math. This is 0 and 1. This bracket here is the closed interval. So meaning to say x can be 0. It could be 0 and it could be also 1. Okay, can you follow? So okay, so at A, what is the state of this A 20 degrees and 0.1 cubic meter per kilogram? This is given. Meaning to say that what? This is saturated, or state is saturated, right? So this is 0 here, it's equal to 0, and x equals to 1 here. So 0.6, this is 0.67, somewhere here. Okay, so this is still a mixture of liquid and vapor that is saturated. This is our point here. Okay, so on the next item we have letter B. We have our pressure is 800 kilopascal, and we have this specific volume given 0.2. cubic meter per kilogram. Before we proceed, any question on the item A? Any question? No question? Silence means yes. So we proceed here. So by looking at the saturation table for ammonia here, so that is T, you have those in degree Celsius, P in kilopascal. And we have this specific volume in cubic meter per kilogram. Okay, so we have a pressure given of in the table we have 16 and 18, and we have this 752 . 752.79, and this is 800, and this is 803. Point 66, and we have this point 1693, and we have 0.1590. And this is our V here at 800 kilopascal. Okay. So by looking at these values in the saturation table, we have the 752 kilopascal and the 800 and 803.66. So these are the corresponding temperatures based on our table. This is 16 degrees Celsius and 18. Okay. So what are the state here? So meaning to say that what? Looking at here, okay, we have the volume, the specific volume of 0.2, right? The saturation values, this is 0.1493 and 0.1590. In between, the 0.2 should be in between, meaning to say the V saturation value here, this is what? This is lesser than 0.2. So if the given specific volume is greater than the saturation, this is our state is superheated vapor. So we cannot use the saturation table anymore because you cannot find the 0.2 there, 0.2 cubic meter per kilogram, right? So now we will use the superheated table for ammonia. So the superheated table for ammonia at 800 kilopascal. So we have T, this is in degrees Celsius, this is 70, and this is 80. This is the specific volume in cubic meter per kilogram. So that is 0.1991, and this is our 0.2 here, and this is our 0.2060. So we'll use the linear interpolation to get the values of our temperature here, temperature of our ammonia. Okay, so linear interpolation. You're familiar with the linear interpolation, right? Yes. interpolation. So by linear interpolation, we have t minus this one, t minus 70 all over 80 minus 70, and this is 0.2. This is 0.2 minus 0.2 minus what? 0.19991 all over 0.2060. So this is by cross multiplication, we can have our temperature is 73 degrees Celsius. So again, at 800 kilopascal and V is equals to 0.2, this state is a superheated vapor. By our definition of the saturated vapor, so we have here 73 degrees Celsius, and based on the saturated table, if we are going to check, okay, so this is our result is 73, which is obviously higher than the saturation temperature, right? Because here we only have 16 degrees Celsius and 18 degrees Celsius, and it should be in between if that is our phase is saturated, or our state is saturated. Okay, can you follow? Any question? Is that clear? Are you there?
Yes, sir.
Mas lisod ni siya, di ba? Compared sa inyong quiz? Or masayo ni? Masayo ni, no? Okay, so if we draw the T V diagram, okay, so this is a mixture of liquid and vapor. Our number one is somewhere here. Or A is somewhere here. And our letter B is superheated somewhere here in this region. Okay, so if it is subcooled, then in this area, in this location, subcooled or compressed. So since it is as we based on our calculation, that this is a superheated one. Letter A is saturated state, and letter B is a separated state. It is separated vapor, and letter A is saturated vapor. Any clarification? Natay pangutana? Si Alger, sa mo to si Alger? None. So again, ako yung i-clarify kung ang imong substance is ammonia nga table sa atong gamiton ha. Ibasig marambol atong nahon na ba nga kining kuan ammonia atong gamit water, or water ang given ang atong gamit ammonia or other substances. Okay? Klaro?
Yes, sir.
So do you your na mo yung mga inyong mga tables sa kuan naman ma-download, no? The saturation tables, separated tables, or the thermodynamic tables. You'll download that one, the thermodynamic tables and the air tables. You don't have to memorize that one because given man siya. So if that given that is saturated, if that is saturated, what you have only one property. For example, if you have a P and the condition is saturated vapor, so you can now find the T. Okay, you can also find the specific volume and so on and so forth, and other properties. Claro? Because of that, we have the pressure is vapor pressure curve, or the P versus the T here. So P is dependent, or they are if P is high, the temperature also will be high. Okay, this is the vapor pressure curve. Okay, so at a given P there is a given temperature if that is saturated. Saturated rin yung ma-apply. Okay, so my advice, you should be familiar with the saturation or the steam tables. Those tables you should be familiar with, because that is your tool in solving those problems in thermodynamics 1. Are you familiar na? Familiar na ba ta?
Wala pa, sir.
Wala pa. So you should practice na. Familiar ni mo mong pangitaon ng values. And like for example, kung wala siya dire, like for example, based on the tables, you have no values here, then you have to interpolate Okay? Wala man diri. You have to interpolate. You can interpolate because you have given other property. Only one property. You have 0.2 specific volume. Then you can now find the temperature. Okay? Any questions? Any question?
Wala na, sir.
Sa'yo na ba nag-answer mo tanan? Cancer na tanan?
Wala pa, sir.
Wala pa. So karon maka-answer ang gid mo. Now?
Wala niya na, sir. Ako po, cancer na dyan.
So this is the difference between the face-to-face and the online class. Supposedly, ingani gid nga tong face no kanang mag-discuss ingani. But some of you wala may load, mas gasto man yung data, di ba? That's why maghimo og video. And other knowledge sa inyo ang effort na. You read and read, practice solving, read the concept. Okay?
Ako'y pangutana, sir.
Okay, what's your question? Kinsa man ni?
Kana sa nag-display sa presentation mo, sir, bang anong 0.2060 lagi na, sir. Aw kanang hindi na siya minus 0.191 Ito, sir.
Okay. Napa ni sa sumpay? 0.191.
Minus.
Ah.
Okay.
Thank you.